gamers, and welcome to another video. Today it's Advent of Code. It's that time of year again, and I really want to see your solutions, so leave those in the comment section down below. If you want to support the channel, there is a link in the description to different affiliates where you can get great deals on things, and there's also a donation link if you want to donate a coffee to me in order to improve the quality of this channel. And day 12, garden groups. Why not search for a chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots, when some elves ask if you can lend a hand. They like to set up fences around each region of the garden plots, but they can't figure out how much fence needs to be ordered and how much it will cost. They hand you a map, your puzzle input, of the garden plots. Each garden plot grows only a single type of plants and indicated by a single letter on your map. When multiplied, multiple garden plots are growing the same type of plant are touching horizontally and vertically, and they form a region. For example, in this 4x4 arrangement includes garden plot growing different types of plants, A, B, C, D, and E, each grouped in their own region. In order to accurately calculate the cost of the fence around a single region, you need to know the region area and perimeter. The area of the region is as simple as the number of garden plots the region contains. The above map ABC plants are each in the region of 4. The E plants are in the region of 3, and the D plants are in the region of 1. Each garden plot is a square, so it has 4 sides. The perimeter of a region is the number of sides of a garden plots in the region that cannot be touched by another garden. In a region is the number of sides of garden plots in the region that do not touch garden plots in the same region. The A and C plants are each in a region with perimeter of 10. A and C. Okay. The B and E plants are each in a region of 8, and the D is in a region of 4. Visually, the sides of the plots are each in a region that contribute to the perimeter as dashes and pipes. The above map regions perimeters are also measured as follows. The plants of the same type can appear in multiple separate regions and can appear with other regions, for example. Can appear within other regions. In the above 5 regions have one containing all of the O garden plots and the other 4 containing the single X plot. The X regions each have 1 area and a perimeter of 4. The region containing 21 type O plants is more complicated. In addition to the outer edge contributing to the perimeter of 20, its boundary with X region contributes to an additional 4 to its perimeter, for a total of 36. Due to modern business practices, the price of fence required for a region is found by multiplying the region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for each region on the map. In the first example, A and B has 4, 10, 40, and so on. Here is a larger example. So the total price is 1930. What is the total price of fencing all the regions on your map? Figure out a region and also all the places it has against any other region. So it shouldn't be that complicated. We first off need a map. We can have a string map here. I don't think the map is super big. And just have char character map new string map like that. And then we have lines size, which is height, and we have width, which is lines get 0 length. So this is width times height. So we can start there simply, and then we do a for string lines for string character in lines splitator outline split everything, and here we can do an if line is blank continue. We don't have any extras, and we need to have a counter here so we can iterate up on the character map. Counter is equal to character, like that. So now we need to also, in the next example here, have a map of string and let's say long for value, regions, hash map, like that. So for x, okay, the y first, 0 to y less than height, y plus plus, there we have that, and then we have the x value as well. So now we need to go through the character map, and we will take the region, if regions contains key of character map y times with plus x. So if that is true, so we can have this as an index. So this is the index where we are working now. So index, what? We can call that a key. It's not an index, it's a key. So if it doesn't contain the key, we take regions, we put the key 0. So we have an empty map here, like that. So now we want to have regions put key calc position of the character map x, y, with, and then the regions get key. So in here we want to, first off, we have a value here. That value we want to add to, because we know that this current region is one such attempt. And then if the character map we can have this string key here as well. So string key. So if the character map and then we have this example again, +1 is equals to key. If that is not true, then we will add one more. And then we have -1. And then here we have +1. We need to use parentheses. And then we do the same for -1. And we're not working with diagonals. So after that, we need to go through and get all the long values of the regions values. Long count plus equals to this long value, and we will take the count and print it out. So if we run this, we get an index out of bounds exception, because we can't do this if x is larger than 1. Then we can do that. And here we need to have y larger than 1. Here we wait to have y less than width -1. Or perhaps -2. And here we need to have x less than height. So we need to have height as well. We always need to have height. So, but I think we need to have 2 here, or else we will get out of bounds as well. See? 228, that's not true. Yes, we need to have the actual plants because it's not a multiplication. So, let's do this. Java class plant, like that, string, and then we have private int area, private int alls, or something like that. And area is 0 and walls is 0. We need to create we need to generate a constructor with only character. Then we need to generate hash map and so on. Next. We don't need those two. Next. So it's only character string that is important here. And then we will have a public long get calc this will return area times walls. We need to have a public void inc area, which just take area plus plus, and we need to have a public void inc walls plus plus. So now we have a plant. So this is a string. We need to have this set of plant, and we need to have a hash set here, like that. So here we need to have to just calculate position, and here we will let's return here again. Let's back up a bit. Let's not make it harder than it is. So this is the plant. We don't need to put anything here. We just need to fetch that. New plant key. We'll create a new plant, and this will just return void. And then we will have plant here, plant inc area, plant inc walls, add to the walls. We don't return anything, and here we will have plant, and this should be p get calculation. So what do we get now? We have some issues there. Closer! Much closer. So let's debug this. So now we have a couple of regions. We have R, we have all of them. So this should have an area of 12 and walls of 12. So walls is incorrect for this one, but the area is correct. So at least we have done one thing right. So I guess we just change these up, because we are doing less than. So that's why. 17, 18. We are closer, but not correct. So let's run this again. And we are back. And today it took a long time to figure this one out. I finally got the right test values after a bunch of work back and forth. And I realized that I needed to keep track on each grouping and then trying to merge them together. So I created this little plant, which could be multiple plants. So it could be an area of plants. And it has a bunch of imports up here, and then I have a list of plants that is contained in the same area. I have an ID of this current plant area, a character of this plant area, the area of this, which is usually just 1, and then the walls around. And the first thing I do when I create this constructor is that I add myself to the list of plants that I control. And then I add the character and the ID. Next up, I have this one we can take last. I have 2 functions here. One to increase the area, which I probably just do once, and then increase the walls to figure out how many walls do I have around me. And then I want to get the key as well, so I can compare that. And because we're using sets where we put things into, I have an equals and a hash function, which is just checking the plant ID and the character. So that's what I want to be equal, or what I want to create my hash code around. This is so you can put it into a set and get unique values in a set. And then I also want to get all the plants in at some point, and I also want to merge. So I want to merge all of these. And what I'm doing when I'm merging is checking if this ID is lower than the plant ID, or vice versa. The reason is because I want to have the thing that has the lowest ID to take control, pretty much, and then I switch it over. So let's say that this ID is smaller than the plant ID. Then I don't think it really matters, but if you don't have it, it will not complete. So that's why I'm having it, pretty much. So if the plant ID is, this plant ID is larger than the plant ID, then I take plant, all the plants for that plant, add this plants to that, and then return plant. Otherwise, I do the same, but with this current object. So I'm pretty much just merging the amount of plants I have in an area, and then the return the one that I merged into. And what I'm doing here is that I'm going through and creating new plants with this function here. And then I calculate the positions for each plant. So I go through the full character map, which should have 1 plant object per square. So I will go through all of those and check them. And in here, we have fetch the first plant, the current position. I will increase the area of that. And then I will go through each direction and see if I have something else than the same kind of plant in that direction. Then I will increase the walls for that. And I can only do that in directions where there is actually available space. But in the case there isn't an available space, it will still be a wall there. So I will add those walls as well. So that's the calculation here. So now I have all separate areas. All the 100 different places has totally different areas, and they know about the wall. So they have one in the area column, and then a bunch of walls. Then I will run through and see, can I merge things together? And I will do this until I can't merge things anymore. I will go through each of these and see, can I merge it, set it to true, and then do another while loop and see if I can merge any more. And the merge function is pretty much take this current plant. I will check if the x value is larger than 0, so I can fetch one previous. I will get the one that is 1 to the left of me and see if I have the same plant key. So if it's the same character pretty much. And I also want to say that these two should not have the same object. They should be different objects. Very important. So if they have the same key but are different objects, I could merge them. So then I will do a merge here with the current plant that I get down, merge with the one to the left of me, and I get the plant back, and then I will replace that object on both places. So I will continue to get more and more areas where they have the same object in a couple of places. And then I do the same for the thing above me. So I will check and try to merge and then push it in there. So that's my merge function. And then I will go through and get all the plants. So this will go through the full character maps and push all the plants into a set, which means that I will just get unique areas. But they will still contain a bunch of different plants. So what I'm doing then is that I take this count, start at 0, count through each, and I do this calculation. So the new area, new walls. And what I'm doing is going through the plants list here, or the plants set, and checking each of them, getting the area and the walls. So this is pretty much just incrementing 1, 2, 3. And then the walls is the number of walls that each of them had. And then I will multiply those two and return that. That will give me a calculation that I print out here. So that is the functionality. The tests work. Let's see what we get if we run the full set. See if it takes forever. It didn't. We got that value. Let's switch back here. And let's see if it is correct. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So let's look at part 2. Fortunately for the elves are trying to order so much fence that they are qualified for bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is. Consider the example again. The region containing A plants has 4 sides, and as does each of the regions containing B, D, E. However, the more complex region plants C has 8 sides. Using the new method of calculating regions per price by multiplying the region's area by the number of sides, region A and E have prices 16, 1632, 4 and 12 respectively for 80. The second example above full have 436, and this one down here has 1206. So this is going to be a little bit more complicated. I think I need to think about this, and I'm still having a work day, so I will not record for hours. But I will get back to you when I've figured this one out. And we are back, and it took a long time with a lot of debugging to figure this one out. I finally got the right result after a lot of walking back and forth and figuring a lot of stuff out. So let's see, first of all, if we have the right solution. So let's run this, and it takes a little while, and we get that value. Let's put that in here. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So we solved part B of the day 12. So what we did here is the same as we did before. We put a bunch of plants into the full map. So we filled up the map with a bunch of plants. And then I calculated positions. So I changed this a little bit. So in this calculate position, when I went through all of these different parts, I also added the wall that I found. So for instance, in this case, when we looked at the right side, I added a wall that I called right. And the same went for left, bottom and top. And then we also needed to add them for the outer walls. So now I have added a bunch of walls. After that, I need, of course, to continue merging things. So in the plant function here, I added to the merge function that it should also carry over all the walls in a new set. So I've added into there's a wall objects. So currently this plant has all the wall objects as well. And then I have this wall, which has a right, left, top, bottom placement. So the wall side and also an XY position. So that's what we create here, and an equals and a hash code, so we can actually have unique walls. So after that, I needed to have a calculation function. So I created this calc object function, which returns big int, and then I went through and fetched all the areas. So that should pretty much be all the plants should have one area. Then I want to go through all the wall objects for this particular plant, and when this plant area, and here is a little bit more complicated, because first, we will run until we don't have any more wall objects. So I will remove wall objects while I count. I fetch the first wall object. I create a set of walls to remove. And if the wall side is top or bottom, we need to move in the X direction to see if we can find any other walls. So I first add this wall, and then I will move right to fetch walls, and I will move left to fetch walls. So we have this difference in X and difference in Y. So I move to those walls, and then we add that we have found one wall segment. And then I do the same for the other direction. When we have a left and right, we need to go up and down to see if we can find more wall sections. And after we have found all the wall sections, we have continuous walls. We will remove all the wall objects we found. And then down here we do the multiplication again. So this walls function, it pretty much goes in here with a wall and a direction. We will create a new set of things to remove. And if we find a wall object that has the X value that is the same as the difference of this wall that we send in, and a Y value with the difference with the wall we send in, and the wall sides are identical, then we will add that segment as well to this continuous wall, and we will continue in the same direction, fetching more walls. And we will break after this, because if we find one, and we don't want to find more, because we can't find more than one segment, of course. And then I will return all to remove. So this was a little bit more complicated, but it seems to have been working. I took a long time for me to figure this one out, but it was write more code and try to create something that explains the problem to you in a good way. So after I had explained the problem to myself, I could figure out what kind of bugs I had in it. It was a lot of debugging as well. I had a lot of values that I set wrong, and I set top bottom when it was right left and so on. So I did a lot of thought mistakes during this process, but when I actually wrote it down and had a clear list of things to accomplish, it's much easier to fix this problem. It's more a thought exercise than actual really hard problem to solve. I hope that you found this interesting. I hope that you learned something today. I would love to see your solutions in the comment section down below. If you haven't subscribed yet, please do that. If you like this video, give it a like, share it with your friends and colleagues, and I really hope to see you in the next video.